In 7.6, we're going to work with rational inequalities and how we solve them. And so a rational inequality is when we're going to have a rational expression, so like a numerator and over a denominator, and it's going to be some inequality. It could be greater than, it could be less than, it could be greater than or equal to, less than or equal to, and then we're going to compare it to 0. And there's a reason why we compare it to 0, because then it has to do with whether things are negative or things are positive. So when we say something is greater than 0, then we mean this is positive. And if we say something is less than 0, then we mean this is negative. Okay, so keep that concept in mind. Also, because they're rational expressions, we have to make sure that the denominator doesn't equal 0. Can't be 0. Okay, so I think that that's going to help us a lot there. So think if you wanted a positive, if you wanted something greater than 0, you could have a positive over a positive, that'd be greater than 0. Or you could have a negative over a negative, and that would be greater than 0. Because a negative divided by negative is positive, right? Okay. If you want something negative, you could have a positive over a negative. That would be less than 0. Okay. Or you could have a negative divided by a positive. That'd be negative. That would also be less than 0. So these are the concepts that we're going to use, and I'll show you how we do these problems. Okay. So here comes our first one. We have a rational expression on the left. We have 0 on the right. So great. And this time it's greater than or equal to 0. So the first thing you do is you look at the factors in the numerator, x minus 2, and you say, when is that 0? And you look at the factors in the denominator, and you say, when is that 0? So you solve those little equations. So you get x equals 2, x equals negative 4. Okay, those are called boundary points. Boundary. And what I do is I draw a number line and I graph the boundary points. So there we are at negative 4, and then here we are at 2. Now this example, we have to look at the symbol which is greater than or equal to. So I could have x be 2, and then my numerator would be 0, and the whole expression would equal 0. So this is a solution. It's part of my solution set, 2. And so I put a solid line because I'm going to be including that. And then I look at my negative 4. Well, if x were negative 4, then the denominator would be 0, and that's a problem. So x cannot be negative 4. So I use a dotted line to say, well, it's a boundary point, but I can't actually equal negative 4. Okay? Now what this does, because I have 2 boundary points, it divides my number line into 3 sections. So I'm going to have the green section in here, the blue section in here, and then I'll have this section be the orange section. And so what we're going to do is we're going to use what are called test points. So I'm going to make a chart, and I'm going to find some test points to try. And what happens is, if my test point works, it works for the whole section. So I'm going to pick a number in the green section, so some number in the green section here. I need a number less than negative 4. Usually people say negative 5, but you don't have to. You could pick negative 10 or negative 20 or something like that. Now what are we testing them? We're testing them in the inequality we were given. This is the inequality we're given. So we're going to plug in negative 5 and see what happens. So I'd have negative 5 minus 2 over negative 5 plus 4. And I want to know if that's greater than or equal to 0. Well, in the numerator I get a negative 7. In the denominator I get a negative 1. Well, a negative divided by a negative is positive, so yeah, it's going to work. Sometimes students like to write this out. That's fine. So Is 7 greater than 0? Yes. So I usually put a smiley face for the sections that work, but you could just write yes or true or something like that. So what it means is all the numbers less than -4 make it true, because the numerator is just going to be negative and the denominator is going to be negative. And negative divided by negative is positive. Okay, so that section works. Now we go to the next section, the blue section. So I need a number between -4 and 2. I'll choose 0, but you could pick 1 or 3. So I'll plug in 0. So I have 0 minus 2 over 0 plus 4. I go back to the statement that we have, our inequality, to see if it's true. Well, what do I get? I get a -2 in the numerator. I get a +4 in the denominator. And it doesn't matter what the value is, really. It's negative, right? So a negative is not bigger than 0. But if you really want to put -1/2, you could. Is -1/2 greater than 0? No. So that section, the blue section, none of those points work, because you're always going to have a negative in the numerator and a positive in the denominator, and that's not going to work. Okay? All right. Then we pick one more test point for the last section. We're doing that in orange. So I need something bigger than 2. A lot of times students say 3, but again, you could pick 100 if you wanted to. But I'll plug in 3. So I've lost my inequality, but it's 3 minus 2 over 3 plus 4. And I want to know if that's greater than or equal to 0. Well, 3 minus 2 is positive, 1. 3 plus 4 is positive, 7. So I have a positive over a positive. That's going to be positive. That's greater than 0. So yeah, this section works. Yes. Okay. So smiley face in that section. All right. Or yes, you can put the word yes. Now, all of that is our work, and it is a lot of work. You've got to find the boundary points, divide the number line up, pick a test point in each section, and see if it works. Okay, now we're going to write the answer, and we're going to use interval notation. So the first section works. That's -infinity to -4. But remember, I'm not going to include the -4, because that would make the denominator 0. So I have to be careful on that. Union. And then I can include the 2. I can have the numerator be 0 because it says greater than or equal to 0. So I'm going to include the 2. And then that's going to go to infinity. And then that's my answer. It's a bit of work. It'll help to watch more examples. So in the next videos, I'm going to do some more examples.